Number 9 says, use the function f of x equals 3x squared plus 4 on the interval from 0 to 2. It says, its graph is provided to the right. Part A says, determine a Riemann sum for f on the interval from 0 to 2 using 3 subintervals of equal length and using right endpoints on each subinterval. So since the graph is given, it's going to be much easier for us just to draw the 3 rectangles and calculate it that way. So the first thing I need to do is I need to calculate the width of each of my rectangles. So that's b minus a over n. So our interval is 2 minus 0 over 3. So each rectangle is going to be 2/3 wide. So if I come to my picture, there's 2/3. If I add another 2/3, I'm at 4/3, and then my third rectangle ends at 2. So because we're using right endpoints, I'm going to go to the right and draw over. I'm going to go to the left, or excuse me, on the right side, draw up to the function, and that determines the height. And then here, I'm going to draw from 2 up and over, and that determines my height of my rectangle. So right to the function, top of your box. So then it says, let's actually calculate this guy. So my subintervals here start and stop 0 to 2/3. The next one picks up at 2/3 and goes to 4/3, and the last one picks up at 4/3 and goes to 2. And because I'm doing right endpoints, these are the values I want to plug into my function. So my Riemann sum, which you can also notate as S sub 3 because it's the sum of 3 rectangles, is going to be my height of my first rectangle, which is whatever f of 2/3 is, times the width of 2/3, plus the height of my second rectangle, which was f of 4/3 times 2/3, plus the height of my third rectangle, which was f of 2 times 2/3. So since all the widths are the same, I can factor my 2/3 out front. So now I just need to evaluate what these 3 values are. So I could actually write it in and simplify it, or you can just leave it explicitly like this. So I could just say, well, this is 3 times 2/3 squared plus 4 plus 2/3 times 3 times 4/3 squared plus 4 plus 2/3 times 3 times 2 squared plus 4, and you can just stop. You don't have to simplify it any further than that. So it's the area of each one of my 3 rectangles. Is your Riemann sum an over or an underestimate for the integral? So the integral is the area under the curve, right? So it's from the function back down. And just by simply looking at our picture we drew, we can see that the rectangles are grabbing more area than the integral would grab. So we can say, well, it is an overestimate. You could mention that the function is increasing, but I think the simpler explanation would just be because the rectangles capture more area than the region under the curve. You just explicitly state what you see happening. All right, then part C says we'll use sigma notation to write an expression for a Riemann sum on the interval using n subintervals of equal length using right endpoints. You do not have to work out the value of the sum, but your sum should only involve sigma, k, n, and numbers. So we've actually already done a little of the pre-work here. So the Riemann sum, our delta x is b minus a, which was just 2, over n. Our value, our x values, using right endpoints, are your a value plus 2k over n, which just simplifies to 2k over n. So be careful. Here we gave you an a value of 0, but if it were a 1, this would be 1 plus this. So a lot of people miss that. Then the heights of all our rectangles is f of ck, which is f of 2k over n. So when I plug that into my function, I would get 3 times 2k over n squared plus 4, which simplifies into 3 times 4 is 12 k squared over n squared plus 4. So my Riemann sum is going to be k equals 1 to n, my width of 2 over n times my height of 12k squared over n squared plus 4. If you want to distribute it out, you can, but you don't have to, because if you were going to complete the Riemann sum, you would probably factor that out and then simplify from there. But you can stop right here.